Without finding squares, find the value of 200 squared minus 199 squared and 50 squared minus 49 squared. Now clearly 200 and 199 are consecutive numbers. Similarly 50 and 49 are consecutive numbers. So we have two pairs of consecutive numbers and you have to tell the difference without finding the squares. Now to solve this problem we have two properties and we have already discussed them. So and the properties were that if you have a number n, and in this case that number n is 199, and if there is another number n plus 1 that is consecutive number to this one, in this case you have 200, right? If you take the square of these two numbers, that is 199 square and 200 square, then the difference between these two consecutive numbers, in this case 200 squared minus 199 squared, this can be solved in two ways. So, and we have discussed them. If you have watched those video tutorials, then it will be as easy as a pie for you. So the first way is that simply add n and n plus 1, n and n plus 1. So in this case n is 199 plus 199 plus 1 is what? 200. So you get 399. See, you can quickly tell the value of this one without finding the squares of these two numbers. And the second way that we discuss, or the property we discuss, is that the difference between these two consecutive perfect squares can be given by 2n plus 1. In this case n is what? 199. So 2 times 199 plus 1. 2 times 199 is 2918, 2918 and 9 and 398 plus 1. This gives you 399. This value and this value, these two values are the same, right? Same thing can be done for 50 squared minus 49 squared. In this case n is 50. N plus 1, that is consecutive number to n, is 50. Sorry, this should be 49. I'm sorry. And this will be 50. So n squared and n plus 1 squared is 49 squared and 50 squared. If you have to find a difference without finding their squares, then you can find in two different ways. The first one is this one, that is n plus 1, that is 49 plus 50, you get what? 99. And the second way is this one, that is 2n plus 1. So 2 times 49 plus 1, so this gives you 98 plus 1, and this is equal to 99. Express 21 squared as the sum of two consecutive positive integers. Okay, now even for this problem we have discussed one property, that is any odd number, any natural odd number other than 1 can be expressed as the square of any odd number other than 1 can be expressed as the sum of two consecutive natural numbers. So this is 21 squared, this is 21 squared, and let's say the two consecutive numbers are n and n plus 1. We have discussed this property. The value of n can be given by, this value of n can be given by 21 squared minus 1 divided by 2, and this value n plus 1, two consecutive numbers, right, can be given by 21 squared plus 1 by 2. Okay, So if you find out this value 21 squared, then this 21 squared is 441 minus 1 divided by 2, and in this case this is 441 plus 1 divided by 2. You get 440 divided by 2 and 440 divided by 2. Sorry, 441. Sorry, I've again made a mistake. 442. I'm sorry. So this gives you what? 220. And this gives you what? 221. Right? So clearly, if this 21 squared is 441, this 21 squared is 441, then first number is 220 and the next number is 221. Right? Can you see that? You can express them. Now, this we solve using a property that we have already discussed. But there is one more way to solve this one. Let's suppose that the two consecutive numbers are n and n plus 1, right? N and n plus 1. Now, I'm solving this without using any property. This was solved using the property. So, the second way is find this 21 squared. What's 21 squared? Is 441. So, 441 is equal to n plus 1. We have supposed that let the first number is n, therefore its successive number will be n plus 1, the two consecutive numbers. Now this is 441, this gives you 2n plus 1, and if you solve it you get 440 is equal to 2n, and from here you get n is equal to 220. So if n is equal to 220, that is this is 220, then n plus 1 will be what? Will be 221. So you can see that we have these two same values.